Mark Twain put it best when he said, "Age is strictly a case of mind over matter. If you don't mind, it doesn't matter." As sharp as his wit may be, for many people, age does matter. Aging starts the day we are born and ultimately ends with our death. Our skin, being the largest organ, also ages. As inevitable as that is, the effects of aging on the skin can be minimized and in some cases even prevented. By the year 2030, 1 in 5 Americans is expected to be 65 years or older, and in the next 50 years, about 1/3 of women worldwide will be menopausal. Clearly, this is a global issue that will run the gamut from anti-aging medicine to anti-aging skincare products. In fact, a recent report published by the global industry analysts stated that the US and Europe dominate the world market for anti-aging products, with anti-aging cosmeceuticals taking the lead. Despite their current dominance, Asia and Latin America are the 2 fastest growing markets worldwide and are expected to continue growing in the coming years. Today, the most sought after non-surgical procedures include Botox and Dysport, along with injections like hyaluronic acid injections. Despite this, skincare remains a very popular and non-intrusive way to address aging concerns without a visit to the dermatologist. These economic trends suggest that the anti-aging skincare market is somewhat recession-proof, and that is great news for the professional skincare therapist. In this webisode, I will cover the differences between intrinsic and extrinsic aging. That is aging simply a factor of time passing, or are there other factors that can prematurely age the skin? Then I'll take you through the biology of aging skin. What is the impact of aging on the epidermis and dermis? And finally, we'll discuss photoaging, a critical factor for premature aging. The next set of webisodes in this aging series will cover ingredient solutions. What is the latest in aging skin ingredient technology, and what can give you results you can actually see? We'll end with the latest treatments and tools for handling the aging skin client. So what exactly occurs with aging on the skin? The biological clock affects both the skin and the internal organs in a similar way. The majority of cells also have life cycles, and just like us, they age. They reach senescence, remaining viable but incapable of reproducing. These natural changes gradually, over time, lead to faulty responses to environmental factors, which eventually lead to cell death. This is the biological clock. Changes also occur partially as a result of cumulative damage due to oxidative stress, or the continuous formation of reactive oxygen species, also known as ROS. Despite a strong antioxidant defense system, damage generated by ROS affects cell membranes, enzymes, and even DNA. Eventually, other molecules and hormones decline as well, resulting in an aging body and aging skin. Extrinsically aged skin is the result of environmental effects on the skin, such as pollution or lifestyle, and of course UV radiation, which is also called photoaging. Think of this as the wear and tear life has on our skin. This is a great example of extrinsic aging. Dr. Derek Antel, a New York-based plastic surgeon, has studied the effects of sun, smoking, and stress on identical twins. Here you see Gay Block and her twin Gwyn. Notice the difference in skin tone and wrinkle formation. Identical twins sharing the same DNA look vastly different due to their environment. The sisters moved apart, and one was a sun worshiper, while the other got relatively little sun. Extrinsic aging can also be the result of our lifestyle. Smoking, alcohol, and poor nutrition can all be factors. Here you see another set of twins with remarkable skin differences. One twin was a smoker, while the other was not. Again, notice the more pronounced lines not only around the mouth, but also between the eyes and even around the eyes. These are classic examples of how our lifestyle and environment can age our skin faster than with normal passing of time. If we were to look under the microscope and examine a section of skin, what would we see? You would see the stratum corneum with skin cells stacked flat and ready to be sloughed off, or desquamate. With aged skin, this cell turnover and cell renewal is slowed. The surface also provides a barrier against the environment and prevents loss of moisture, also called transepidermal water loss. An impaired barrier function can lead to dehydration and ultimately result in fine lines. When it comes to skin, there are 4 major distinctions between young and aged skin: epidermal thinning, wrinkles, a flattened dermal-epidermal junction, and collagen fragmentation. Let's look at the aging epidermis first. The The aging epidermis is characterized by a thinner appearance and slower cell turnover rate. Between our 30s to our 80s, our turnover rate slows from 30 to 50%. This lengthening of time corresponds to a slower replacement of the outer skin cells and also decelerates wound healing. Older people can take twice as long to replenish their cells after dermabrasion resurfacing compared to younger individuals. Combined with the less effective desquamation, the result is excess stratum corneum layers that look dull on the skin. In the epidermis, there is a decreased number of melanocytes and Langerhans cells, or the skin's immune cells. The reduction in melanocytes produces the mottled pigmentation evident in elderly skin, which is more prominent in sun-exposed skin due to stimulation by ultraviolet radiation. The most obvious changes are at the epidermal-dermal junction, the region just below the epidermis but above the dermis. The DEJ zone is an undulating region with finger-like projections of the epidermis and dermis interlocking with each other. Here, you can see the dermis in green and the epidermis in pink. These projections are called reed pegs and aid in bringing nutrients and oxygen to the stratum basal layer via capillaries. This is critical for cell division. A flattening of the DEJ means less surface area, resulting in fewer nutrient transfer from epidermis to dermis. This impacts cell division rate in stratum basal and also contributes to the overall thinning of the epidermis. What happens to the dermis as we age? There is a loss of dermal volume as well. There's even less nutrient transfer as blood vessels are reduced in numbers. Reduced sensory innervation of skin nerves into the skin is also seen with age, which may explain why certain sensations are blunted with age. The dermis and hypodermis become atrophied with a reduction of collagen and certain glycosaminoglycans, or GAGs, and adipose tissue of the hypodermis. Collagen is an important component of the DEJ. Collagen forms a highly cross-linked network necessary for mechanical stability and support. GAGs are important in the dermis for consolidating collagen fibers and participate in skin hydration. Reduced collagen and GAGs with age or sun exposure can weaken this mechanical stability and allow the formation of a wrinkle. These reductions also give place to the skin that is less elastic with a weaker structure. Skin appendages are also affected at this level. There's a decline in sweat gland numbers and sebum, terminal hair turns to vellus hair, and loss of melanocytes and hair bulb result in graying hair. The stratum corneum lipids are crucial in preventing penetration of foreign material into the skin while preventing transepidermal water loss. As we age, the amount of lipids produced by our skin decreases. Several other external factors like stress, overexfoliation can also strip the lipids of our skin, which is particularly important in older individuals. What happens to our skin through the ages? In our 20s, because it's probably at its healthiest with great collagen support, skin is supple. Whatever sun damage you may have has not yet started to show for the most part. Cell turnover is about 14 to 25 days. In your 30s, you may start noticing fine lines and wrinkles, especially around the eyes and mouth. You may notice discoloration and uneven skin tone. Skin may be thinner as there's some collagen loss. Cell turnover has begun to slow down, making complexion a little dull. Cell turnover is about 30 days. In your 40s, cumulative sun damage appears in the form of blotchiness, red spots, and even ruddiness. You lose more collagen and elasticity, and the skin retains less moisture. Cell turnover is around 40 days. Now in your 50s and beyond, there is more dryness and loss of elasticity. Expression lines no longer disappear after you stop smiling or squinting. Pores are more visible, especially in the nose and cheeks. Spider veins and hyperpigmentation may now be visible, along with precancerous spots from sun damage, such as actinic keratosis. In women, menopause can even result in dryness, decreased elasticity, and loss of dermal volume. Cell turnover can take at least 50 days. UV radiation is the most important factor in extrinsic aging, especially in premature skin aging. UVB alters skin structure mainly at the level of the epidermis, where most of it is absorbed. Here, it can damage DNA in keratinocytes and melanocytes. UVA penetrates more deeply into the dermis and plays an important role in the pathology of photoaging. It causes oxidative stress, mainly by production of ROS. In photoaged skin, collagen fibrils are disorganized and elastin-containing material increases. UV radiation increases the production of collagen-degrading enzymes, such as the matrix metalloproteinases. Many skin cells, including immune cells like Langerhans cells, pigment cells like melanocytes, and signaling molecules that trigger inflammation, are all altered with UV radiation. Of course, the culmination of DNA damage from UV rays is skin cancer, which is prevalent in certain climates, especially in lighter skin or 1 to 3 on the Fitzpatrick scale. The mainstay in the prevention of skin aging is photoprotection. Putting it all together, let's look at the anatomy of a wrinkle. Wrinkles are folds of the skin, more frequent on the face and hands. They appear more in sun-exposed areas. The thinning of the epidermis stratum spinosum is actually worse at the deepest part of a wrinkle, where other markers of epidermal differentiation are all diminished. Gag reduction is also more pronounced at the bottom of a wrinkle compared to the walls. At the base of the wrinkles, less collagen is found. This instability deepens the wrinkle formation. On the other hand, the stratum corneum of a wrinkle is often thickened by accumulation of corneocytes, forming what's known as a horny plug. In photoage skin, the elastic tissue grows abnormally in a process called actinic elastosis. This elastic tissue forms pads on the walls of the wrinkle, but is thin at the bottom of a wrinkle. So as you can see, wrinkle formation is the overall result of numerous changes in different skin structures. Reactive oxygen species remain one of the most important contributors to skin aging. The skin is very susceptible to damage by ROS or oxidative damage. Oxidation is one of the key processes in decay of plants and animals. Imagine a freshly cut apple exposed to air. It turns brown. This enzymatic browning is the first step in the apple becoming oxidized and decaying. ROS are also referred to as free radicals because of their highly reactive nature due to an unpaired electron in their chemical composition. ROS damage can cause lipid peroxidation, which is damage to cell membranes resulting in premature aging, skin cancer, and even cell death. The body has a natural defense against oxidative stress via the activation of antioxidants. They include vitamins like vitamin C and E, minerals, enzymes like superoxide dismutase and catalase, and naturally occurring proteins all found in our bodies or through our diet, which is why diet is also very important. However, when these defenses become overwhelmed, free radicals will cause damage. On the skin, this means wrinkles, hyperpigmentation, and inflammation. Matrix metalloproteinases are a collection of enzymes that degrade or break down the extracellular matrix in the dermis. Each MMP is a family of enzymes responsible for breaking down a specific component of the matrix. Examples are collagenase, elastase, and hyaluronidase, which respectively break down collagen, elastin, and hyaluronic acid. MMPs are critical in remodeling connective tissue, which is an important process in aging and wound healing, and they're only called to action when needed. However, inflammation and UV radiation will also call them to action and can result in disorganized and clumped collagen, characteristic of photoage skin. Moreover, the natural inhibitors of MMP in skin are diminished with aging, resulting in more MMP action and less collagen. The good news is that MMPs can also be inhibited by topical agents such as retinoids. Advanced glycation end products, or AGEs, were first identified in cooked food as end products from the non-enzymatic reaction between sugars and proteins. In the kitchen, it is the process of browning meat or toasting bread. AGEs are the result of a process called glycation. Glycation occurs slowly and affects aging, as well as several different diseases. Glycation results in AGEs and free radicals, which contribute to the cross-linking of protein fibers or the loss of elasticity associated with aging. The net result is that elastin and collagen cannot be broken down, so the skin becomes stiff and yellow-brown. As we age, there is a higher risk of glycation-induced damage on the skin. For this reason, it is important to prevent the action of AGEs and prevent future oxidative damage. These biochemical changes, combined with the natural progression of aging, bring about fine lines, wrinkles, pigmentation, texture changes, and loss of tensile strength. By focusing on repair strategies, we can minimize or halt the activity of overactive MMPs, AGEs, and destructive ROS. We can also help rebuild the dermal matrix to support the skin. Of course, we can prevent accelerated aging with effective sun protection as a key strategy, followed by antioxidants and vitamins. Thank you for joining us for today's webisode. To review what we've shared today, click on the link on our Facebook page and be sure to take our short survey so that you can get an exclusive booklet for this webisode. To learn more about aging skin, make sure you also visit dermalinstitute.com. to see our current class offerings and our articles.